In this figure, a smaller square and a quarter circle are inscribed in a bigger square. The diagonal of the bigger square touches the top left vertex of the smaller square, and the arc of the quarter circle also touches the top right vertex of the smaller square. If the length of the side of the bigger square is 8 units, find the area of the smaller square. To solve this problem, let the length of the smaller square be x. Next, let's focus on this small triangle. Notice that the small triangle is a right triangle. And this angle is 45 degrees. This is because it is the half of the angle at the corner of the square which the diagonal bisected. If that is the case, the remaining angle of this triangle is 45 degrees. Reason: sum of angles in a triangle. Now, observe that this triangle is an isosceles triangle, since the opposite angles are equal. Which follows that the two sides of this triangle are equal. Since this side is x, this side will be x. And the remaining length of this side of the square will be 8 minus 2x. Next, let's extend this line to DC. And also draw another straight line from the top right vertex of the smaller square to D. Let this point be E, and this point F. Now, observe that DE is 8 units, that is the radius of the quarter circle, which is the same as the length of the side of the bigger square. FC is equal to the length of the smaller square, which is x. EF is equal to 8 minus 2x. And DF is equal to 8 minus x. Next, let's focus on triangle DEF. Triangle DEF is a right triangle. So, from Pythagoras Theorem, DE squared is equal to DF squared plus EF squared. DE is equal to 8. DF is equal to 8 minus x, and EF is equal to 8 minus 2x. If we go ahead and plug in these values in the above equation, we will have 8 squared is equal to 8 minus x squared plus 8 minus 2x squared. Simplifying this equation will give us 64 is equal to 64 minus 32x plus 4x squared plus 64 minus 16x plus x squared. 64 will cancel out. And we are left with 0 is equal to minus 32x plus 4x squared plus 64 minus 16x plus x squared. Collecting like terms will give us 4x squared plus x squared minus 32x minus 16x plus 64 is equal to 0. And this will give us 5x squared minus 48x plus 64 is equal to 0. And this is a quadratic equation. Going further, we are going to solve this equation using the quadratic formula method. Given a quadratic equation, ax squared plus bx plus c equals 0. The quadratic formula for this equation is x is equal to minus b plus or minus the square root of b squared minus 4 times ac all over 2a. Comparing these two equations, a is equal to 5. B is equal to minus 48, and C is equal to 64. If we plug in these values in this formula, we will have x is equal to minus 48 plus or minus the square root of minus 48 squared minus 4 times 5 times 64 all over 2 times 5. Simplifying this will give us 48 plus or minus the square root of 2304 minus 1280 all over 10. 2304 minus 1280 is 1024. So we have 48 plus or minus the square root of 1024 all over 10. The square root of 1024 is 32. So, we are left with 48 plus or minus 32 all over 10. Let's simplify by dividing through by 2. 10 divided by 2 is 5, 48 divided by 2 is 24, and 32 divided by 2 is 16. So we are left with x is equal to 24 plus or minus 16 all over 5. For plus x is equal to 24 plus 16 all over 5. 24 plus 26 is 40. 40 divided by 5 is equal to 8. 4 minus x is equal to 24 minus 16 all over 5. 24 minus 26 is 8. 8 divided by 5 is equal to 1.6. The length of the smaller square must be less than 8. It follows that the side of the smaller square is equal to 1.6. To find the area of the smaller square, the area of a square is given as L squared. If we substitute L with 1.6, it follows that area is equal to 1.6 squared, which is equal to 2.56. Thanks for watching. If you liked this video, make sure to subscribe for more.